I will now start my presentation about our own C-file-based system called heiBOX. First of all, I would also like to thank and also congratulate the C-file, the main members of the C-file company on their success. Yeah, I didn't know that. I just also talked with him privately, so I didn't know that C-file existed for 10 years now, and that's quite an accomplishment in my opinion. And without C-file, we all wouldn't be here. So yeah, thank you again for the very well written software that you provided for us. Yeah, and also thank you for the invitation. There was I didn't even know that this event existed until you wrote me. So I'm quite happy to be here so far. And yeah, thank you very much. My name is Marc Brendel. I am today representing the University of Heidelberg. And I am the group leader of the service group Cloud, it's called in the University Data Center. And we provide different cloud services. We have our own private infrastructure as a service cloud. We have a cloud service like heiBOX based on C-file and some other services as well. And yeah, that's our, let's say, main domain where we administrate services. Today, I will give you a short introduction to heiBOX, like what is heiBOX and how is it used. Then I will go into the architecture of heiBOX, how did we build it. Next up, I was asked initially, because I didn't know what kind of presentation to give, what I should present, and it was like, yeah, maybe some challenges that you had with C-file. And since we run C-file for quite a few years now, there are some interesting stories regarding C-file, and I brought two of them with me today that I will explain in more detail. The last thing is current projects that we're working on that are related to C-file, but not, as was presented before, directly integrated into C-file. But you'll see what I mean when I get there. All right, first of all, heiBOX. It was launched, production launched in early 2016, but there was an initial test version. Back then, it was not my service, but I remember it. I think in 2015 we had another, let's say, alpha version, also based on C-file, and apparently my supervisor and the people who administrated it liked it very much, so we kept it and launched it productively in 2016. It's a sync and share service for all members of Heidelberg University. We currently have, I mean, it changes year by year, but currently we have almost 9,000 employees and almost 30,000 students. And employees get 30 gigabytes base quota, but they can enhance it if they are willing to pay for it internally. And students get 10 gigabytes each as well. A feature that is heavily used, and I hope you never, ever remove it from C-file, are the guest accounts. And we currently have around, that's almost 4,000 guest accounts. They can't own libraries, but for our researchers in a university environment, it's super easy to share and collaborate with external partners. I'm not sure people who work in a university know it can be a real hassle to get an account, an internal account in a university environment. And this completely circumvents it, and all of the researchers are quite happy that they can simply invite people to our service and give them access to data without relying on download links, for example. So, awesome feature. We currently, I don't have all the graphs with me. Now I regret, yeah, now that I saw that everybody else brought it. We have currently around 90,000 libraries in our system, close to 35 million files, and around 85 terabytes of data. There is still some data in there. You mentioned that you cleaned up your system. I'm now disillusioned because I was hoping we would get a lot of storage space back when we start, but I don't think that's the case anymore, so we'll see. But that's the current state of our system. heiBOX is used for, we had like small discussions before, or some questions like, what is the system used for? Of course, we cannot say it in all detail. Yeah, we don't monitor every single use case of our users. We get some insight from tickets, from questions of users. We hear some stories about how C-file is used in our campus. So we get like a, let's say, an idea how it's used. One of the main things is our administration is using it. And I say our administration, in a university environment, there is a single central administration, but there's also a lot of decentralized administrations, yeah, and everybody can basically do what they want. So some of them use C-File quite heavily, and they really like it. Others use different systems. It's very rare that we only have one system for a specific purpose. In most cases, it's 2 or 3 systems. Yeah, that's just how a university environment sometimes works. The second part is it's used not directly for, of course, scientific research, because you share files with it. You don't do any kind of research with the system, but to collaborate with external partners, to share some data with them. Some of them might even have used, and I will get to it later, to publish some parts of for the scientific data, so they use it for that, and basically just to get information either between different groups in the university or to external partners. Then the third part that really took off with, of course, the corona pandemic, teaching. Even though we have, again, multiple other systems that we also suggest that they use. For example, we have a Moodle, we have an OpenCast installation. You can't tell everyone in a university what to use. That just doesn't work. So a lot of people started using heiBOX to just upload their basic teaching materials. And we also see a lot of cross-access from Moodle to heiBOX, so this is still going on. So some teachers just decided I will upload my videos and all the teaching materials to heiBOX and give students the link. So that's also what we saw. But this is just me trying to categorize or at least give you some kind of idea what the service is used. Of course, there's things that are basically crossing those boundaries. Yeah? If a student has his master thesis, we strongly advise them to do some sort of backup for it. And we offer them a service that has versioning integrated into it. And this, of course, doesn't fall either under, like, maybe teaching, maybe part scientific research. So there's, of course, also a lot of other use cases. Yeah, some people use it for their coding files, yeah, use it like a Git repository. So, but that's to give you a small idea what the system is used for, what kind of data is on there. Let's get to the architecture part. So, first of all, I will try to split it and try to explain all the parts of our infrastructure. We start with the, let's say, the foundational basic block, or one of the most important parts. In here, you see the background server. We use also a C-File installation like it was in the manual. Our Elasticsearch is hosted on this background server. The background virus scans are done from this server. And we also do, I think I heard you say it, we also have some scripts running there. Yeah, we do garbage collects from the background node, for example, and we have some other maintenance tasks that we also, the node is just the best option to run these tasks from. Then we have a memcached, not cluster, but 2 instances that run in active-passive fashion. As I mentioned earlier when we had some Q&A, we haven't noticed that a failover impacts the system much for us, but there needs to be a memcached instance, definitely, or otherwise we get some problems. That's why we have an active-passive setup, so we can just do basic system updates on one node, and we have a seamless failover to the other node, and everything is running fine. Then we have web servers. We don't co-host anything on these web servers. We just have the C-File, C-Hub component, the reverse proxy, and because we offer virus scans on the web servers as well, we have Clam AV installed on there, but there's no database part, no memcache part, nothing on there. We debated initially, because we redesigned the system, to also co-host some of the things, but we decided against it because I think it was also mentioned earlier, let's say, what we call web server part is completely stateless. Yeah, so we currently have 5 web servers in production, but we can scale in and scale out on demand, yeah, without having to think about database replication or anything else. So stateless system is always perfectly suited for scaling out. That's why we didn't co-host anything. Next up, we have MariaDB Galera cluster, something I've heard a few times before now here. We also run this in an, let's say, even though it's a multi-master system, yeah, by design, we run it also in an active-passive fashion, but we don't use a load balancer in between, and we also don't use, I actually thought it was quite a clever idea to run HA proxy locally, but we didn't think of that back then. So we use a virtual IP. Yeah, just the same, or I forgot to mention, we use also for memcached, we use a virtual IP. We use the Virtual Routing Redundancy Protocol, VRRP feature of KeepAliveD to just have a virtual IP and that can move. And it's the same in the database cluster. Yeah, so database 1 is usually the one where all the traffic goes. And we also don't see any bottlenecks there so far. If we would see it, we would be prepared to do a read-write split or something like that, but that's not necessary at the moment at least. So yeah, we have a database cluster. We didn't have any deadlocks, but we had, I think there was an initial problem with the Galera configuration where we had to restrict one type of worker to a single thread. But there was a bug report for that and everything else, and after that it worked fine. And we didn't have any problems whatsoever afterwards. The next component, we heard a lot of storage systems already. We have our own S3 storage that that is hosted on-premise with us. And yeah, coincidentally, it's also one of the systems that our group is administrating. So we also know the service very well. And I will get to one funny story later on, but we didn't have any problems with using S3. I unfortunately could not answer if we had a performance increase, but at least there is nothing where we would say, oh, if we didn't have S3, then we had less problems or anything like that. So we're super happy with using S3. Then the part where how the connections get in, we have a load balancer pair, and that's also in an active-passive setup. We also use KeepAliveD there. We had HA proxy before, but we moved away from it because we wanted, and I thought I would be the first guy to say, but we also do DSR, direct server return, load balancing, and HA proxy cannot do that. I tried really hard to get it to work, but it didn't work. So we just switched to KeepAliveD, and we can use DSR load balancing for that. Our service is, you haven't mentioned it specifically, but our service is yeah, globally available, which is not a given thing for a service in a university. And also for us, a lot of services are now moving behind VPN for us, because we see a lot of universities or more and more getting attacked. And that's why there was a call made to move services behind VPN to protect them. We will not do this with C-File. We can't. Yeah, we have external researchers who need to access it. They will not get an account in our system to use VPN and then go to heiBOX. So we will stay a globally available service. The ingress path, it was explained before. I will just explain it again. The ingress path goes from the client to the load balancer, and then we use a sourced IP-based hashing algorithm to ensure that each client always gets to the same web server, if it's available, of course. KeepAliveD offers to use the maglev hash for that, for people who want to understand it more deeply. And for the egress part, it goes directly to the virtual router and back to the client. We thought, I mentioned we had a different system in place. One part was, of course, we wanted to learn and had this idea, hey, it would be really cool if we could get the traffic to go directly back. And so it was kind of a, let's say, research project. We learned a lot about load balancing. But in the end, for us, the advantages of this type of load balancing are first, the latency is reduced because the extra hop here is removed. We wouldn't worry too much about overwhelming the load balancers, but it also allows us to scale the download capacity with the amount of web servers. Because initially, that was before we launched the service for students, and we didn't know how many students would access our C-File service. So we thought, hey, the use case basically is one guy uploads a file and 10 people download it. So the download capacity should be bigger than the upload capacity. And this form of load balancing is just ideally suited for it. In combination with having stateless web servers, if we see we don't have enough download capacity, we just add another web server. Problem solved. That was the initial thought then behind it. yeah, that's basically the architecture. We have additional, I would say, core technologies that are an important part of our system. You may have seen that everything is virtualized. They're all VMs. We have our own private infrastructure as a service cloud called heiCloud, which we also administrate ourselves. That's like the third main service of our group. It's based on OpenStack, and our whole system, heiBOX, apart from the S3 storage, is hosted on OpenStack. And since we know OpenStack by heart, we were the administrators of the system for years, we could utilize all of the features that we were aware of. And it was really fun to, I received customer tickets before and tried to work with them. And this was the first big service that we migrated to our own cloud. So for me, it was really interesting to see the other side. And we learned a ton about OpenStack as well. One of the things this enables us to do is we can distribute the VMs of each group on different compute nodes. Yeah, it's called an anti-affinity group. It was mentioned in the exascale presentation. We use that feature for heiBOX as well. So we have 3 Galera cluster nodes, and we ensure that each VM is always on a different compute node. So if one compute node fails, then the Galera cluster is still is still functioning. The same for the web service, the same for the load balancers, and the same for Memcached. So a single node failure in the underlying cloud does not kill the whole heiBOX service. That's the thought behind it. The second feature that we really enjoy is the on-demand scalability. We have different virtualization services in Heidelberg University. We had Hyper-V before. We have a VMware cluster as well, but none of them offer the self-service part that a cloud solution really offers. Yeah. So this allows us to simply scale VMs up or down, or out or in. Yeah. We don't have to ask another team, hey, we need 3 more VMs configured with this. No, we can just do it ourselves. What we also could do, but what we don't currently do, we could do auto-scaling as well on demand. We could see our web servers are at, 20% capacity. We can scale it down to 3. Then we see, oh, it rises to 70%. We can add another web server, or maybe 2, and then we would have auto-scaling in there. Yeah? But we didn't have time to implement that. I would have really loved to do it, but we didn't have time, and now sadly it shows we don't need to. Yeah? The system is working perfectly fine as it is. And also as the heiBOX service owner, we don't have to pay the heiCloud service owners money for the amount of VMs, so it's perfectly fine that way. But still interesting maybe in the future. The second part, we automate. We are also a very small team, it was mentioned before, and we automate everything. And the main tool that we use for years now is Ansible. We use Ansible for the infrastructure deployment, so we orchestrate OpenStack and everything in OpenStack, security groups, virtual networks, VMs, everything with it. And we also configure the VMs themselves with Ansible. So we use it for both. Although I'm starting to think of an alternative, at least for the OpenStack part, maybe I wanted to switch to Terraform, and now I'm not sure if all of you are aware, but there's been some discussion about the licensing of Terraform. Now there's a fork called OpenTofu, and now I don't know what to do for now. Yeah, we'll see how this works out. If we would switch to Terraform by HashiCorp or to OpenTofu, I'm not sure, but we might replace that part. It works perfectly well, but Terraform is, in my opinion, the better suited tool to manage infrastructure as code in that way. But Ansible is fine as well. The third part, very important and always growing, and we always try to improve it, is our monitoring system. We have a centralized monitoring system for all of our services, also for the cloud. And we use Grafana Loki to ingest log files from all of our systems. And we use Prometheus to ingest metrics from all of our systems. I looked it up yesterday. We ingest, just for heiBOX, we ingest around 8 million log lines per day, and works perfectly fine. That is like a super small fraction of the logs we ingest. heiCloud and S3 generate way, way more logs, but it works perfectly fine for us. We also have a decentralized monitoring part, where we use Monit on each VM. And we One thing is it's a fallback mechanism, because a centralized component, even though it's a cluster as well, it could always fail. Yeah, it cannot send emails or some other alerts because of some network issue or whatever. So we have a second path for monitoring. And we also use Monit for things that we could not do or could not as easily do with a centralized component. For example, we have a Monit check in there that tries to download a file from the local web server. So we really have the end-to-end check in there. Not just, hey, is CFI running? Hey, is Apache running? No, can you download a file from the local web server? And if that's not possible for, I think it's like 3 times in a row, if it fails, then it automatically restarts CFI, because most likely this would fix the issue. That's what we would do if we had to log in. So we just automated it and use Monit for something like this, which makes the service even more robust, as it already is. Yeah, so it's basically like self-healing, and that's what we use Monit for, at least in heiBOX. Yeah, that's the picture of the architecture of heiBOX. Next up, I will talk about some of the challenges and some of the lessons learned. I will start with quite a while ago, and maybe Daniel and Jonathan might remember, because we wrote a lot of emails back then when this happened. And we did an upgrade from 7.0 to 7.1. And we noticed all of a sudden that the connections between the web server and the database servers had some issues. Yeah. At first, we only saw like some logs, yeah, MySQL connection error, and then we were like, okay, what is this? We tried to monitor the network connection between the nodes, even though we were pretty sure that there was no issue. We still tried to monitor it more in depth. So we sent a check every second to the database. We saw for, I don't know, 6 hours, there were 0 issues with the database, let's say, ping connection on all web servers. So we kind of ruled it out, and then we went deeper. And what we noticed, what we didn't know before, was that this is not just like a single connection, but that there was one connection per SQL query. And we didn't know back then how it worked. We, of course, tested the upgrade on our test system, and we had no issues, yeah, whatsoever. So this only appeared once we moved to production. So yeah, we learned that for each query, there was one database connection made. We dove even deeper, and we noticed that the same thing was happening for the memcache connections. Yeah, and also there we had intermediate errors. We had to do a bit more extensive logging to see those errors, but then we saw, okay, this is the same issue. So we could start to rule out it might not be something with just the database or just the connection between web server and database, because memcache is also affected. It's unlikely that we broke the database and memcache at the same time. But CFA was also working in our test cluster, so we were a bit confused, yeah? And then we were starting to dig even deeper. And we also got help then from CFA to analyze the problem better. And yeah, what made it really urgent is we could reproduce the issue then in our test cluster by simply spamming F5 in a browser, yeah? And we could take at least a single web server down in our test system. So we were sitting there crossing fingers, hoping that none of our users are bored enough to just spam F5 in the production setup, yeah, and hope that we can fix the issue before it really affects users, yeah. Users were intermediately affected, yeah, some error came sometimes, but we didn't get like a lot of tickets for that. But we were still, yeah, working on it with high pressure because we knew how easily it would break. Yeah. The thing is, what you see here, these connections, these are not cables. Yeah? It's a virtualized environment, so there's a lot of, let's say, network magic happening in the background. And what we figured out, finally, because we were also the cloud administrators, there is an SDN in between. Yeah? And the SDN uses a technology, I will explain it shortly, that's called a token bucket for the creation of new network connections or network flows. You can imagine it just as a bucket, and for, let's say, each time frame for, let's say, per second, you get 10 tokens into the bucket. And then you can create, for each token, one network connection. And the next second, you get 10 more tokens. Yeah? There's also some burst limit, whatever, but we exceeded these tokens with the single connection per query. and the single connection per memcache command. So the web servers were not allowed to create new network connections. Yeah, so then we knew at least what the root cause was, but we could not simply remove a token bucket from our underlying cloud. Yeah, that would have been a way bigger issue. So at that point, we desperately wrote to CFI, and I think Jonathan was directly involved even. And we needed some solution from CFI. And the basis that finally fixed the problem after some tracing and debugging, where we also got help, and at this point also special thanks to you that you helped us so fast after we identified the issue. The database connection pooling in the CF server component was removed. In most environments, people didn't notice, yeah, because it didn't cause any issues, but in our cloud environment, it caused a huge issue. So we asked if we could have a toggle or a reintroduction of the feature. We got I think it was a pre-release version then that we could test, where we could verify, yes, this fixes our problem, perfect. And then we could roll it out in production before we had any major outage. What we also did, because now we understood the mechanism behind it, we also adapted the C-Hub config, and later on, I think I just did that 3 months ago, another part of the C file config, to also use persistent connections everywhere, also to memcached. So that's a, let's say, special adaptation. That's a few config options, and we had to adapt the way Junicorn works. I think I remember that I asked if this is still supported, and I got a yes back, but ever since then, our service is way more stable. Yeah? But that just shows, I guess most people here would never have this issue, but we in our cloud environment indeed did have this issue. But since database and memcache connections are both TCP-based, in our mind at least, this could also pose a performance impact on every single C-file service, potentially. I brought some data from our monitoring. This was during the, let's say, peak phase of our year, when the semester is actually ongoing, so C-file is more heavily used. And this is the commands per second that get sent to memcache. Like all commands, yeah? There's a get command, write command, whatever. It's all summarized. And as you can see, we have a mean value of, let's say, almost 3.3K commands per second. And for each of these commands, because it's TCP, there needs to be a three-way handshake first, otherwise there's no data. Then you get the data back. And at worst, you need 4 more packets to tear down the connection. And that is happening over 3,000 times per second. And it's the same for the database. It might not be like a huge performance impact, especially since C-file is also, the main issue is I want to synchronize files. Yeah? But for a web application, this would be, or a pure web application where I need super fast response times, this might be an issue. So we just adapted it. It made sense because we didn't want to ever run into the token bucket issue again. But we think that this might also have a positive performance impact on the whole system, and we try to keep that in mind also in all of our other systems. Yeah? I mean, we have more services that use databases, for example, or that use some sort of caching service, either it's Redis or Memcache. So we try to take this learning and also apply to other systems. But that's just to maybe keep in mind that this could potentially have a performance impact in other systems as well. All right, that was the first story. I also have a second one. This initially happened in 2021. And the only thing we initially saw in our monitoring system was that the connections between the web service and the S3 storage, or rather the amount of operations per second, increased up to 20-fold. So we were like, okay, we've never seen this much in our S3 system. What's going on? And there were no errors. The web servers and the whole C-file installation was also not unstable. So we saw, like, I looked it up yesterday, it was like a peak of 50% CPU usage across the web servers. And database servers were fine, Memcache was fine. Everything was okay. There was more network traffic, but way below the threshold we have in our system. So C-file itself was fine, but S3 was not. Yeah, it was starting to struggle a bit. So we try to investigate what the hell is going on. Now I brought a graph as well, and this is in retrospect. We saw some parts during, and as you can see, we have, let's say, kind of low traffic, and then we started to get a peak. The first day was 10 terabytes per day download. Yeah. The second day was up to 25. Here we have even more than 25 terabytes per day downloaded. And here we went back. This is where we applied the mitigations that I will show you now. And then ever since, even though we mitigated it, it stayed up. So I think right now we also still have a let's say, average download of like 5 terabytes per day around, just because of what I'm about to show you. So yeah, we were puzzled, not overly alerted, but still puzzled, and we wanted to check out what the issue was. So we have our service heiBOX, and we investigated, and we also adapted our logging and monitoring system after that, because we noticed that it was, even though we had all the information, it was really clunky to get it. Yeah, we had different systems. We had to look into different log files everywhere, and then we adapted our monitoring system, so we will catch this in the future way earlier. But we noticed that we get a lot of access from Google Cloud Platform VMs, like a lot of Google Cloud Platform VMs. And the initial thought was, oh, is it finally happening? Is this the day where we get DDoSed? But CFA itself was not struggling, it was just S3, so yeah, we thought, no, and if it would be a real DDoS, CFA, everything would be down. Yeah, if we ever get a real DDoS attack, then nothing will protect us from that. But we investigated it further, and we noticed all the connections were focused on just 2 download links. And we then figured out in what library those files were located, who created the download link. We spoke to the person or the people who created these download links and asked, what did you do? Why are there so many downloads on just these files? And yeah, in the end, it turns out there was a scientific publication for, back then it was still called latent diffusion when the paper was published. Now you might know it as stable diffusion. That was way before the hype for ChatGPT, Midjourney, and co. But Stable Diffusion is another AI tool to generate images from text. Yeah? And they did a scientific publication. And to make it reproducible, they provided a download link to a pre-trained model, yeah, so that other scientists could verify that this is working. Yeah? And they didn't tell us. Yeah, we didn't know what was going on. Was it like, what kind of event would cause this? So yeah, and then we talked with them, and then we said, okay, I think initially they took down a link for at least some time, yeah, so we could fix this issue. But afterwards we were like, okay, we never explicitly prohibited anyone from using heiBOX like this. So we just try to mitigate the issue somehow and leave the files on heiBOX. But yeah, that was quite fun. What we did to mitigate it actually, we started to at least limit the maximum throughput per source IP because we could not, S3 could not handle this much traffic from these many Google Cloud VMs. Yeah. We still don't know if it was just like crawling or if people were like all trying to spawn a GPU instance, clone the repository, download the files from heiBOX, and then run their own Stable Diffusion. No idea. But we just limited it. We still have that limitation in place. So there's a throughput limitation for external access. There's a higher value for internal access. Also internally we have, I mean, it is starting to change, but most people don't have 1 gigabit per second at home. But for us, it's like the standard in offices. So we did not want to restrict the people in the campus that were working or working through VPN too much. But we also could not let Google Cloud VMs get unrestricted access to our service. So that's the limitation. We used IP tables hash limit for that. We then learned about a hash limit, and we also applied it to other services as well. Also, since we're also a cloud provider, we always have it in the back of our minds to avoid this noisy neighbor phenomenon. Yeah? Just because somebody has like a 100 gigabit line doesn't mean that they should be able to impact the service for everyone else. Yeah? So that's the basic thought behind that, and we try to apply it to all of our services so far successfully. We also try to limit, because I thought, maybe someone is really is starting to get clever and just starts multiple downloads or tries to split it up, and we also limited the amount of parallel connections. Just in case. This also protects from other attacks that I later on learned. For example, slow LoRa's, where a lot of connections are built up to a server and are never really utilized. Yeah, they just wait and then send a packet, wait again, send another packet, so the server cannot tear it down. That's also applied in our services now per default. And the last thing, and we had to contact CFile again, I tried to find a solution on my own. The problem was not that CFile couldn't handle it. Yeah? The problem was that S3 was getting hammered with requests. So we thought, hey, if there was some form of caching, if the web servers could just directly give the file back, we would have no issue. Yeah, we have way more than that as capacity in our network. The web servers can handle this fine. So I started to investigate. I actually tried to get it working as a proof of concept with Varnish. Not sure if any one of you has ever worked with that. But the problem is we don't have the, let's say, the knowledge of the service itself. Yeah? Because only CFile knows when a file is updated, and an external caching system, if there are headers, it could check them, but there were no headers that could be verified. So we would have to either guess when a file would be updated, or we would have to set a limit. So the cache would have given out stale data. And so we asked, hey, maybe it would be a cool feature to have in CFile, and we wrote an email. And indeed, we got a caching feature in CFile, so that the web service would be able to give back files without putting too much load on S3. So thank you very much again for that change. Very helpful for us. And yeah, that was the second, let's say, interesting, I hope, story from our usage of CFile in heiBOX. Let's get to the current projects. Final slide as well. I think I hope I'm not too much over the time limit. Okay. I mean, there's always a lot of stuff that's going on, stuff that you try out, but it has, the focus that we have right now in the system is very much on security. It was also a focus from the start. We have, for example, very strong network isolation in our cloud deployment. It was mentioned before as well in the talk. For example, if you would, for whatever reason, be able to breach one of the servers, one of the web servers, that doesn't mean you get SSH access to anything else. Yeah, that's not possible. The service is only available from the outside on port 80 and port 443. And there are a lot of restrictions just from the way we segmented the network. Also, our web servers and our memcache servers and our database servers, they don't even have a public IP. So even if we screwed up the security groups somehow, the firewall rules, you would still not be able to access it. It doesn't have a routable IP, so that also protects the service. We also have network and process monitoring in place already, though it can always get better. And we have some layer 4 firewall rules as well on the system. So for example, we reject fragmented packets. We reject TCP packets with, let's say, funky headers that don't make any sense. That gets dropped on the load balancer already. And of course, with the monitoring, we can see what's going on. But there's still a part missing. That's just a lower layer, let's say, and some application data. So one of our apprentices, actually it was his final project this year, he started to implement a web application firewall based on mod security. Not sure if anyone here heard it. And integrated into our Apache web server. It went okay in the test system. It's not as easy as we didn't think it would be easy, but it's a lot more complex to do web application firewall for a service like CFI. Yeah, for example, if I have a static website, I don't assume that a lot of data gets transferred from this website. Yeah, that would be very suspicious. But for a single share service, that's like the main thing it's there to do. Yeah, so we had to put in a lot of exclusions for now. We have also deployed it in production in a log-only fashion to get some data and to see what would be blocked. How can we adapt the rule set to make it work, for example, with the CFI client, the C drive client. They all behave like slightly differently with the web server. And so we evaluate how we can implement this in production properly without breaking the service. Yeah, the initial idea, or why we would want to do this, was actually the Log4Shell incident. And CFI was also potentially affected by this. I actually found out how to use the exploit in CFile. I think I had contact with both of you even, and we tried to get it fixed and then tell people how they can secure their CFile instances. But that was really the point where I wish I had a web application firewall, because then we could have just implemented. I think there were even, it didn't take long, like a few hours, and there were custom rules available on GitHub. Yeah, we could have just taken it, put it in mod security, and we would have been safe as well. Yeah, because not every issue can be mitigated by some configuration changes. Yeah, sometimes you don't have another choice. You have to, in the worst case, shut down the service. And we want to avoid that in the future. We want to have a web application firewall for visibility, of course, and also that we can be protected against like basic attacks. Yeah, for example, some sort of injection attacks, which can occur at the moment. And we have to rely on, let's say, or only rely on the programmers to sanitize every single input that goes to the database. But there can always be something that is missed. And a web application firewall, it's not perfect, of course, no solution is, but it's an extra layer. So even if there would be a potential issue, we hope that the web application firewall might protect us against that, or at least alert us that this was happening. Yeah, because before with just, let's say, Apache or Nginx logs, you have no way of finding out that somebody is even trying an injection. Yeah, it doesn't show. The second thing that I started as a small side project before my vacation was to implement a host intrusion detection system. We already had the idea a few years ago to use AuditD for this, but we didn't, I think we didn't have time to properly finish it. And now I found another system, it's called Falco, where we try to get some runtime security in the system. So Falco is basically monitoring syscalls on the whole system. It has a kernel module, but that's the old way of doing it. And it has two different, one legacy, one modern eBPF module that can be used. And we will implement this in, of course, heiBOX, but also in other services. And we get alerted on stuff like, hey, there was a binary replaced in the system. That can't be right, yeah? Or, hey, there was a file edited under /etc, whatever. Like the system provides more visibility into what is going on the host as well. So if somebody should, we have a monitoring for that as well, coincidentally, where we can monitor if, for example, the Apache service if the Apache service is ever spawning a process called bash or sh, then something is majorly wrong. Yeah, we have monitoring for that already, and now we have even more extensive monitoring that we can extend with simple YAML rules. So we'll see how this works out, and if it doesn't impact the service, I don't think it will. To be honest, it doesn't even show in the monitoring when I activated it. So, but we'll still test it thoroughly and see if we can implement it in the whole CFI cluster, and then we have yet another layer of extra security. And yeah, then we'll see what the future brings. Yeah, now I'm at the end of my presentation. Thank you very much. And I would say we can go to the questions and answers part if anyone has questions. Yes.
And the first argument or the first point I always recommend is, okay, try to stop or to just take out your web application firewall and check if it works again. It's so often the case that the persons don't know how to use or how to configure the web application firewall, and they're just blocking away all the important stuff and wondering like, oh, why is it not working anymore? Why are no files are delivered anymore? Because
yes.
As we said, CFI is a single chair solution, and it's not like any kind of normal web-based
yes.
Application more complicated to configure a web application firewall in the right way, and I'm quite surprised. Oh no, you confirm what I expected, that it's not easy.
No.
It's not easy, it's not an easy task. Yeah, but it's good to see that it's working.
As our apprentice would confirm if he would be here. Yeah, it's not an easy task. Yeah. For example, delete and post operations are prohibited in the default rule set. Yeah, CFile immediately breaks. We even had an issue where the load balancer is doing health checks on the IP. Yeah, using an IP address in the host header is also not like the usual way you use a web service. Yeah, that's kind of suspicious because most big range scans only use IP addresses. Yeah, so we went through a few iterations, and we also had to exclude the CF HTTP and CF def. Also, we have WebDef activated, and we had to fully exclude those endpoints. Yeah, because we would have. I mean, our apprentice had his final project. It was 40 hours, and that's really stretching it. Yeah, he did. As our apprentices, they always do more, but it would have been impossible to do it in 40 hours with figuring out all the rule exceptions that we really need for also all clients. Yeah, that's the next point. I also told him, hey, you tested the CFI client, but there's mobile clients as well. There's a C drive client. There's different operating systems. I'm not sure if they all do the same calls. And then he was like, okay, can we just exclude it? And then, yes, we can, at least for now, and we will start to collect data. But I'm also not sure if we can ever get it to fully work with all the endpoints. But if at least the C hub component, yeah, where, for example, an SQL injection is most likely to happen, yeah, because we have the authentication form or the full text search bar or whatever, where user input gets accepted, then it at least is a bit more secure. Or we can at least see somebody is trying something, yeah. And that's also better than, hey, we have no idea that this is even happening. So, but yeah, it's a difficult task to implement it for such a system. So we'll see.
Question about the cluster. Which version of the MongoDB are you using?
I have no idea. Sorry. No idea.
Okay, more questions?